Hello and welcome. In this video I want to talk about infinite limits. Suppose we have a limit of a fraction function like p of x over q of x, which p and q are polynomials, and x approaches a. If, as x approaches a, numerator or p of x approaches a non-zero number, but denominator or q of x approaches 0, typically, this limit is equal to positive infinite, or negative infinite, or the limit does not exist. The sign of the infinite can be determined by the sign of the quotient of the numerator and denominator. If the sign of the quotient will be positive as x approaches a, the limit equals positive infinite. If the sign of the quotient as x approaches a will be negative, the limit equals negative infinite. But in some limits, it is impossible to determine the sign of the quotient as x approaches a, and in such cases, the limit does not exist. Before we find our first infinite limit, let me show you by some numeric examples why a non-zero over 0 can approach infinity. For example, consider the fraction 1 over 0.01. If you calculate this fraction in your head or by a simple calculator, it is equal to 100. Another example, 2 over negative 0.001. It is equal to negative 2000. And another example, for example, 1 over plus minus 0.001 equals plus minus 10,000. In these three examples, you can see that as the denominator of our fractions become smaller and smaller, the value of our fractions become larger and larger. So from these examples, we can get an intuition that a non-zero number over something that approaches 0 approaches infinity. Our first example, limit of 1 over x minus 1 squared as x approaches 1. As usual, the first step to find the limit is to plug in the value. If we plug in 1 for x, we have 1 minus 1, which is 0. 0 squared is 0. So the limit equals 1 over 0. 1 over 0, which is a non-zero number over something that approaches 0, is our clue that the limit of this function can be positive infinite, negative infinite, or does not exist. To figure out which one is the answer of our limit, we should try to find the sign of this fraction. In top of this fraction we have 1, which is a positive number. But in the denominator, we have 0. Maybe you think by yourself that 0 has no sign. You are right, but note that this is not a real 0. It only means that our denominator approaches 0. It is not a real 0. It only means that denominator of our fraction as x approaches 1 approaches to 0. So we should try to figure out what is the sign of our denominator as x approaches 1. In denominator, we have x minus 1 squared. We know that any expression that is squared is always positive. So it doesn't matter that x approaches to 1 from the left or from the right. In either case, x minus 1 squared is positive, because any positive or negative value to the power 2 is always positive. So we can conclude that as x approaches 1, denominator of our fraction approaches 0 from the right. So the top was positive, the bottom is positive, and the value of the limit equals positive infinity. We can find this limit easily by looking at the graph of the function as well. If we approach to 1 from the left or from the right, in either case, the y values of the function increase without any bound. It means that the value of the limit of this function as x approaches 1 equals positive infinity. Another example. Limit of 1 over x plus 2 as x approaches negative 2. If we substitute negative 2 for x, in the denominator we have negative 2 plus 2, which is equal to 0. So the limit will be equal to 1 over 0. Because we get 1 over 0, we know that the limit of our function can be positive infinite, negative infinite, or the limit does not exist. To figure out which one is the answer of this limit, we should find the sign of the denominator of our function as x approaches negative 2. We know that as x approaches negative 2, x can approach negative 2 from the left, or x can approach negative 2 from the right. If x approaches negative 2 from the left, the values of x are close to negative 2, but their values are less than negative 2. For example, we can consider x to be negative 2.1. Negative 2.1 plus 2 is a negative number. So we can conclude that as x approaches negative 2 from the left, x plus 2 is always a negative number. It's a very small negative number. 1 over a negative small number approaches negative infinity. Because top is positive, bottom is negative, total or fraction is a negative number, approaches negative infinity. But if x approaches negative 2 from the right, the values of x are close to negative 2, but their values are greater than negative 2. For example, we can consider x to be negative 1.9. Negative 1.9 plus 2 is a positive number. It shows that denominator of our function as x approaches negative 2 from the right is always a positive number, is a small positive number. And the limit of our function equals positive infinite in this case. Because the left limit and right limit of our function are not equal to each other, the limit of our function as x approaches negative 2 does not exist. Of course, we can find the limit of our function as x approaches negative 2 by looking at the graph of the function. If x approaches negative 2 from the left, the y values of the function decrease without any bound. It means that the limit of the function approaches negative infinity. But if we get closer and closer to negative 2 from the right, the y values of the function increase without a bound. It means that the limit of our function as x approaches negative 2 from the right equals positive infinite. So the left limit and right limit around negative 2 is not equal to each other, and the limit does not exist. Another example. Limit of negative 2x plus 1 over x minus 1 as x approaches 1. If we substitute 1 everywhere x appears, we have negative 2 times 1 plus 1 over 1 minus 1. Negative 2 times 1 equals negative 2 plus 1 equals negative 1. 1 minus 1 equals 0. So we have negative 1 over 0. Because we get a non-zero number over 0, we know that the limit of our function will be equal to positive infinite, negative infinite, or the limit does not exist, depending on the sign of the denominator as x approaches 1. As x approaches 1, x can approach 1 from the right and x can approach 1 from the left. If x approaches 1 from the right, the values of x minus 1 is positive. For example, if you consider x 1.1, 1.1 minus 1 is a positive number. But if x approaches 1 from the left, x minus 1 is a negative number. So the denominator of our function has not a constant sign as x approaches 1, and like the previous example, the limit does not exist. Of course, we can find the left limit and right limit as x approaches 1 and then conclude that the limit does not exist. But in a multiple choice question, we need to get to the answer in a short time. So we don't need to go to the more detail that we need only in long answer questions. But if you like, you can find the left limit and right limit. as follows. The left limit as x approaches 1 from the left will be equal to positive infinite, and right limit will be equal to negative infinite. You can check these answers by yourself. I leave it to you to find the left limit and right limit separately and check that the left limit will be equal to positive infinite and the right limit will be equal to negative infinite. But note that we don't need to waste our time in finding the left limit and right limit separately and then conclude that the limit does not exist. Because we cannot find the sign of the denominator as x approaches 1 because it doesn't have a constant sign, we can immediately conclude that the limit does not exist. Note that if instead of x minus 1 in denominator we had x minus 1 squared, it was always positive because it is squared. But in this case, x minus 1 has power 1. It is whole to the power 1. So it doesn't have a constant sign, so the limit does not exist. And of course, again, we can find the limit of this function as x approaches 1 by looking at the graph of the function. As you can see, if we get closer and closer to 1 from the left, the y values increase without bound. It means that the left limit equals positive infinite. But if we get closer and closer to 1 from the right, the y values decrease without bound. It means that the right limit is equal to negative infinite.